This section examines hydrocarbons. Petrol, diesel, LP and natural gas are all hydrocarbon compounds. Hydrocarbon emissions react with other compounds in the atmosphere to produce photochemical smog. Hydrocarbons are a major source of motor vehicle emissions. Petrol needs to evaporate easily to burn properly in an internal combustion engine. But this property also means it evaporates easily into the atmosphere at ordinary temperatures and pressures. When a vehicle is being refueled, hydrocarbon vapors can escape from the filler neck into the atmosphere. When the vehicle is left in the sun, its temperature increases and fuel evaporates from the tank and, if there is a carburetor, from it as well. An evaporation control system is fitted to modern vehicles to collect and store the hydrocarbon vapors from the tank and the carburetor. Then, when conditions are suitable, these vapors are then drawn into the intake manifold and burned as part of the combustion process. In a petrol engine vehicle, during an engine cycle, some of the gases escape past the piston rings into the crankcase. This is called blow-by. Some of these blow-by gases mix with heated vaporized oil and can usually escape out into the atmosphere. Modern vehicles direct these gases and vapors back through the inlet system to be burned during normal combustion. Hydrocarbons can also be part of the exhaust gases. In a four-stroke petrol engine during valve overlap at top dead center, some intake charge is drawn out of the combustion chamber into the exhaust port. Raw fuel, a mixture of hydrocarbons and air, is released into the atmosphere. When combustion occurs in the cylinder, the walls, piston and piston rings are slightly cooler than points closer to the burning mixture. Some of the air and fuel molecules come in contact with these cooler parts and they cool down until their temperature becomes too low for combustion to occur. They are left unburned, and when the exhaust port opens, they leave the cylinder. Misfiring of the ignition can result in unburned fuel leaving the cylinder when the exhaust port opens. If an excessively rich air-fuel mixture is used, there is too much fuel for the quantity of air. Combustion will be incomplete, and any unburned fuel will leave the cylinder through the exhaust port. If an excessively lean mixture is used, then combustion takes longer, and the flame may extinguish before it is complete. When the exhaust port opens, unburned hydrocarbons will be exhausted from the cylinder.